This is the second part of the video on graphing parabolas using the vertex and the intercepts. Notice this is a different form. In the last video, our equation was in standard form where it was very easy to name the vertex. Here, the vertex is not obvious, so we have two choices. One choice is to complete the square, which you should know how to do already. If we complete the square, we'll get it in standard form, and we can name the vertex. Or we can use this new formula. Looks complicated, but it is very easy to do. Here's an equation to begin with. What you need to do to start is name your a, b, and c. A is in front of x squared, b is in front of x, and c is your plain old number. And then all we have to do is plug into this b over 2a. Don't let this right here bother you. What we're doing right here is finding the coordinates of the vertex. This is my x coordinate, this is my y coordinate. So to find the x coordinate, I just need to plug in this information right here. So I'm going to have negative 4 over 2 times 2, which is negative 4 over 4, which gives me negative 1. Negative 1 is the x coordinate of my vertex. I need to find my y coordinate. Recall that f of x is the same thing as y. So this right here is telling me how to find the y. It's telling me to apply the function to negative b over 2a, which is my negative 1. So once you do negative b over 2a and get this answer, all you have to do now is plug in that negative 1 into that function where you see x. So I have 2 times negative 1 squared plus 4 times negative 1 minus 6. Do the arithmetic. Negative 1 squared is a positive 1 times 2 gives me 2. 4 times negative 1 is a negative 4, and the negative 6 just tags along. Do your arithmetic there, and you get negative 8. So the vertex on this is negative 8. Here's another one where I'm just going to ask you to find the vertex. There's my function. There's my naming of the a, b, and c. Here's your formula rewritten just to remind you what we want. So to get started, we're just looking at that formula right there, which is negative of b, which is negative of negative 7, over 2a, which is 2 times 2. Negative, negative turns into a positive, which gives me a positive 7/4. So my x coordinate of my vertex is 7/4. What I have to do now is some pretty ugly fraction arithmetic. If you're using a calculator, this is not bad. Just plug it in exactly as you see it with the parentheses, and you're going to get the correct answer. If you don't have a calculator, here's the steps you have to go through. You will start with 7/4 squared minus 7 times 7/4. Order of operations says square this is how we get 49/16. 7 times 7 is how I get 49/4. In the next step, I canceled 2 into 16 and got 8. 49/8 minus 49/4 minus 4. Get a common denominator of 8ths for everything. Put this all together and we get negative 81/8. So my ordered pair is 7/4, common negative 81/8. There's my a, b, and c numbers written down. We know we need to start with negative b over 2a, so this is just negative of negative 2 on the top, all over 2 times 1. So that's going to be 2 over 2, which is 1. So the x coordinate of my vertex is 1 comma something. All I have to do is plug 1 into this up here, so this is 1 squared minus 2 times 1 minus 15 makes it 1 minus 2 minus 15 is a negative 16. So after the vertex, we have to find the y-intercept, and we know that means just compute f of 0. So plug 0 in for all of those x's is going to give me this. Of course, all of this just goes away, and we just get negative 15. So the y-intercept is negative 15. We could write it as an ordered pair, 0, negative 15 if you want. To find the x-intercept, then we are going to set the equation equal to 0. The best way to solve this is going to be to factor it. Factors is x minus 3 times x plus 5. Because it's multiplication equal to 0, we can use the zero products property, which says set that equal to 0, set that factor equal to 0. And you have two simple equations to solve to get those two x-intercepts. So let's pay attention to our increments. We're counting by 2's here, so 1, negative 16 is over halfway down about right here. Has a y-intercept of 0, negative 15, which is about right there. And then my x-intercepts of 5, 2, 4, 5 in the middle here. Negative 3 will also be in the middle about right here. Off screen, I went ahead and drew this because I knew it would take me several attempts to get it to look right. So that is our parabola that has a vertex of 1, negative 16, and those particular intercepts. New problem. I need a, b, and c, which is right there for us. I need to do negative b over 2a, which is negative of negative 4, which makes positive 4, over 2 times negative 1. So this is 4 over negative 2, which is negative 2. So the first part of my vertex is negative 2. Now I have to do this arithmetic to get the second part of my vertex. So this is negative of negative 2 squared minus 4 times negative 2 plus 5. Negative 2 quantity squared is a positive 4, but we still have that negative in front. So this is negative 4. Negative 4 times negative 2 is a positive 8, plus 5 is going to give us 9. So the vertex of this parabola is negative 2, 9. Let's find the y-intercept, so we compute f of 0. So we're plugging 0 in for each of these, which just makes a big fat 0, plus 5 gives us 5. So the y-intercept is 0, 5. To find your x-intercepts, then you're going to solve this equation set equal to 0. Factoring rules are kind of funky if you have a negative x squared, so I would suggest you factor a negative 1 out, which is going to change all of those signs. The next thing I did here is think about just you can divide both sides by negative 1, because 0 divided by negative 1 is 0. Negative 1 over negative 1 cancels out, so that negative isn't in the picture anymore. Now that it's factored equal to 0, set them each equal to 0 using your zero products property and solve. X equals negative 5, x equals 1. So we have a vertex of negative 2, 9. So we're counting by we're counting by ones. So negative 2, 9 is about right here. A y-intercept of 0, 5. X-intercepts of negative 5 and 1. Now, this is looking kind of strange, and the reason it's looking strange is because it was a negative x squared. We know that this is going to be an upside-down parabola. So off screen, I drew it for you, and that's my rendition of the parabola, but we do know it's upside down because of the negative. Let me review again why we do what we do to find these intercepts. We are computing f of 0 to find the y-intercept because the y-intercept has an x coordinate of 0, and when you're doing f of 0, you're letting x equal 0. Same idea down here when you are doing the x-intercepts, then the y value is 0. So we set this equal to 0 because this is my f of x, and we know that f of x is the same as y.